Hi guys, and welcome to the first in a series of short videos for this section. The first one is arc length of circles. So we're going to be calculating the real life measurement of an arc on a circle. We use this to calculate distance around parts of circular objects, and you'll know you're successful when you can find the length of an arc in a circle labeled with units. Okay, so remember that the definition of an arc is a portion of the circumference of a circle. Arcs are measured in degrees in correspondence with their central or inscribed angles. So, if I were to draw lines from here to here to represent the central angle, we could put a degree measurement that is equivalent to that central angle. What we're going to be discussing now is how do we translate those degrees into real life measurements. So we do that by using arc length. The length of an arc is different from its measure. Remember that measure is equal to degrees and length is equal to units. Arc AB in the circle has a measure of 60 degrees corresponding to the central angle of 60 degrees, but it has a length of 18.85 centimeters. To calculate the length of an arc, we are going to find the portion of the circumference that it covers. And that is calculated by knowing the measure of the circumference, and then you must which is the diameter times pi. And then we are also going to need the measure of the arc in degrees. And you're going to take the circumference and you're going to multiply it by the degree measure divided by 360. So let's take a look at some examples. I have a circle with a radius of 8 and a central angle of 120 degrees. So that central angle of 120 degrees means that this arc here is going to also be 120 degrees. So to calculate the arc length, I'm going to need to find the circumference times 120, because that is the measure of the arc that we are referring to, over 360. So, to calculate the circumference, I'm going to use the formula that the circumference is equal to the diameter times pi. And so if I plug in what I know, right now I know that the radius is 8 centimeters. So that means that the diameter is double that, or 16 centimeters. So I'm going to plug 16 centimeters into my circumference equation. So the circumference is equal to 16 pi centimeters. And I'm going to keep it as the exact answer. This is the exact answer right here, because it becomes easier to calculate when I plug it into my equation. So I'm going to take the circumference now and I'm going to plug it into the arc length equation. So the arc length is equal to 16 pi over 1. And I'm doing the over 1 thing because I am multiplying by a fraction. 120 divided by 360. I have to redo that. 120 over 360. So what I am going to do is take 16 and multiply it by 120. So 16 times 120 is equal to, I'm actually not going to put the equals there. I'm going to put this here. So arc length is equal to 1,920, which is 16 times 20. And then I'm going to write the pi, because we didn't get rid of it. So it's 1,920 pi divided by the bottom, which is 1 times 360, or 360. And so now I'm going to divide 1,920 by 360. And I get a decimal 5.333 repeating, but we're not going to, so you could write it like that. That would be all right. Arc length would be 5.33 repeating pi. I would prefer that you have your answer in a fraction. So 1,920 over 360 actually reduces to 16 pi over 3. So our arc length is 16 pi over 3. And if you type that in, that's the exact answer right there. So that answer that we just got is the exact answer. I want to make my text small. This is the exact answer. So if I'm going to make the approximate answer, what I am going to do then is type 16 pi into my calculator and then divide the answer by 3. So it is approximately 16.8 centimeters. And we would write centimeters for the units here too. So let's try another one. The length, find the length of arc PQ in the circle below. Give your answers as exact and then approximate. Okay, so I'm trying to find the length from P to Q here. The measurement that I'm given, 260 degrees, is around the circle this way. So the measure of angle A is actually going to be 360 minus 260, which is 100 degrees. So since measure of angle A is 100 degrees, we're going to use that amount for the arc length in here. But first, I need to find the circumference. So the circumference is equal to the diameter times pi. I know that the radius is 144. So that means that the diameter is 288. And they didn't give me units, so we're just going to stick unit, U for units on there. So that means that the circumference is equal to 288 pi. So then we're going to plug that into our arc length formula. So the arc length is equal to 288 pi over 1 times the 100 over 360. So we're going to go ahead and multiply those out. So 288 times 100 gives you 288,000. So we get 288,000 times pi over 360. So let's see if we can reduce it, and I know we can, but let's see what it reduces to. It reduces to, if you divide 2,880 or 28,800 by 360, you get an even 80. So it's 80 pi as the answer, and that's the exact answer. And so the approximate one would be when I type in 80 times pi into my calculator, and it would be approximately 251.3 units. So that would be units as well. Units are 251.3 because it's 0.32, and we're going to round to the nearest tenth. So there's my approximate answer. All right, and so now we're going to work backwards here. The length of arc AB is 6 pi. So this over here is actually 6 pi. Find the exact and approximate length of the radius. Okay, so we're going to work the formula backwards. So remember that arc length is equal to the circumference times the arc measure in degrees, theta, over 360. So if we put in what we know the arc length is 6 pi. We don't know the circumference. We're going to need to calculate that. And then, but we do know, we're going to put c over 1 actually. So I'm going to erase that. and I'm going to put c over 1 because we're multiplying fractions. 40 over 360. So we can go ahead and multiply the two fractions out. So we get 6 pi equals 40c over 360. So now the tool that we're going to use is we're going to cross multiply. So we're going to put 6 pi over 1 now, and then we're going to multiply 1 by 40c and 6 pi times 360. 6 times 360 is 2,160 pi. I'm just multiplying the 6 by the 360 and attaching the pi equals 40c. So then I'm going to divide both sides by 40. So I'm going to take 2,160 and divide by 40, and I get 54 is equal to the circumference. So now what I can do is put 54 pi, excuse me. I can take 54 pi inches and substitute that into the circumference formula. So the circumference of the figure is equal to the diameter times pi. So if I take this and I substitute it in here, my new equation becomes 54 pi equals the diameter times pi. So then I can go ahead and divide both sides by pi. And I get that the diameter is equal to 54 inches. Well, we know that the radius is equal to half of that measure, so the radius would be 27 inches. Boom. And finally, a real-life example. So a pizza is cut into 8 pieces. The pizza is an 18-inch pizza. What is the length of the crust from the piece that is taken? Okay, so we have to do a little bit of inferring here. I'm actually going to draw a circle, and the center is here. Okay, we would cut the pizza into 8 equal slices. So here would be 1, here would be 2, here would be 3, and here would be 4. Okay, so we have 8 equal slices for the pizza. Since they're all the same, we're really just dividing the pizza into 8 pieces. So we would take 360 degrees and divide it by 8. And that will tell us the degree measure of each slice of pizza. So 360 divided by 8 is 45. So each pizza slice is 45 degrees. It says the pizza is an 18-inch pizza, so going across the pizza would be 18 inches. So then we're all set when it comes to using the diameter for the circumference formula. So the circumference would just be 18 pi, 18 times pi. So we will go ahead and substitute that into the formula. The arc length is equal to 18 pi times 45 is the measure of a slice of pizza, 45 degrees over 360. So we're going to multiply 18 times 45. So on the top for arc length, I get 810 pi, and on the bottom I have 360. So I'm going to divide 810 by 360. I get 2.25, which I know as a fraction is equivalent to 9/4. So the arc length would be equal to 9 pi over 4 inches. which that's my exact answer. But because we're dealing with a real life situation, we would take the approximate. So 9/4 times pi is equal to 7.1 inches. So that's it for arc length, guys. Arc length, remember that it is a physical measurement of a portion of a circle circumference. Unlike the measure, it has units instead of using degrees. And then we can also work backwards to use the arc length to find the radius of a circle as well. So that's it for this video, guys. Thanks for watching, and I'll see you in the next one.